let's start this recording. Recorder. Yes. And I want to start. Hopefully, does this mean that this is still recording? Recording. Okay. And now, record. Start. Okay, then. So, let us start. Okay, good. So everyone can see and hear me. So let's start. Okay, so let's do the answers here. Okay, so problem number 1. For the given functions f and g, find the requested function. Okay, so I want to determine f minus g at x, where f of x is x plus 6 and g of x is 7x squared. Well, that's your answer. It's two-part problem number 2, which is determine f times g, where f is 2x cubed minus 1 and g is 3x squared plus 1. Okay, well, that's your answer. You could multiply this out. So by the distributive property, let me simplify this. And so this is equal to 3 times 2 is 6. X cubed times x squared is x to the 5th. 2x cubed times 1 is 2x cubed. Negative 1 times 3x squared is minus 3x squared. Negative 1 times 1 is minus 1. And that is your answer. Lastly, next, let's determine f divided by g. So f divided by g at x is just f of x, radical x, over g of x, 5x minus 6. And that is your answer. Next, let's determine f divided by g. Okay. Which number are you on? This is problem number 4. So problem number 4, f divided by g. So f is x squared. It is too small. Really? That's huge. Can you see that? Okay. And so f of x is equal to x squared plus 4 cube root of x divided by g of x, and g of x is just x minus 3. And that is your answer. Okay. Better. Okay, good. Okay, so let's find the following composition. And so you want to determine g composed with f at 4. So first, let's determine, first, that was a error on my part there. I hit the wrong thing. Let's first compute f at 4. Okay, and so f is just equal to x squared plus 5x. So plug it in 4, you get 16 plus 20, 36. And so f g composed with f of 4 is just g of f of 4. Well, f of 4 is 36. So let's compute g of 36. Well, g is just x plus 2. 36 plus 2 is 38. And so g composed with f at 4 is 38. Let's compute. Don't do that. Let's compute. Okay, sorry. Let's compute f composed with g at 0. So let's first look at g of 0. Well, g is just 2x. 2 times 0 is 0. F composed with g at 0 is just f evaluated g of 0. Well, g of 0 is 0. So this is just f at 0. So let's compute f at 0. Well, f, problem 6, is just the square root of x plus 5. Well, 0 plus 5 is just 5. And so f composed with g at 0 is the square root of 5. Let me do problem number 7. So let's first compute g at 25. G is the square root of x. Well, the square root of 25 is 5. And so this is f of g of 25. And g of 25 is 5. So let's compute f of 5. F is just x squared minus 8x plus 8. And so that's equal to 25 minus 40 plus 8, which is, let me see, 33 minus 40, negative 7. Yes. Okay. Let's compute. Let's do problem number 8. Oh, let's compute f composed. It is very small. Then let's do this. Let me do this instead. I'm going to do the following. Okay. Let me do the following. Yeah. Let's do the following. I'm going to get rid of this. Okay, I'm going to do it this way. Okay, so now you should be able to see, oh my goodness, that's a really big screen. Okay, so let's start over again. Hopefully you won't mind too much if you couldn't see it before, but so let's do exam number 4, because we just started. Okay, review. So problem number 1, f of x equals x plus 6 g of x equals 7x squared. I want to find f minus g. So this should look much better now. So f is x plus 6, g is x squared. And it should look really nice. The screen hasn't come back for you. Oh, guess what? Let's do this then. Let's do okay. Now has it come back? I tried to change screen resolutions on you. So, uh, has it come back yet for anyone? Oh, okay, finally. So sorry about that. Okay, so now it should look much better for everyone, because now it's yeah. So now it's the sideway view. Of course, you won't be able to see the this test because it's the other way. But hopefully you have the test in front of you. Um, you know, yeah. So this is better than nothing. So this way you don't have the I can't do it on the test, but at least everyone can see what I'm doing. Okay, problem number 2. F of x is 2x cubed minus 1. G of x is 3x squared plus 1. So determine f times g. So f, 2x cubed minus 1. G of x, 3x squared plus 1. Multiply. 2 times 3, 6. X cubed times x squared, x to the 5th. 2x cubed times 1, 2x cubed. Negative 1 times 3x squared, negative 3x squared. Negative 1 times 1, negative 1. Oops. Okay, let's try that again. And that is my answer. Problem number 3. F of x is rad x. G of x, 5x minus 6. Compute f divided by g. And so rad x divided by 5x minus 6. Okay. Problem number 4. X squared, oops, f of x equal x squared plus 4 rad x. Please bring back 4. 3, probably. Yeah, okay. Sorry, I'm going faster because we already did these, so. G of x is x minus 3, and I want to compute f divided by g at x. So x f divided by g. And that's your answer. Okay. Problem number 5. So when I get to back where I was before, I'm going to slow down to a normal speed. So problem number 5, f of x equals x squared plus 5x. G of x equals x plus 2. Compute G composed with f at 4. F evaluated at 4 is 16 plus 20, 36. G evaluated at 36 is x plus 2, 38. Therefore, G evaluated at f at 4 is G evaluated at f of 4. F of 4 is 36. G of 36 is 38. Let me do problem number 6. F of x equals rad x plus 5. G of x equals 2x. Find f composed with g at 0. G of 0 is 2 times 0, 0. F of 0 is rad x plus 5, which is the square root of 5. Therefore, f composed with g at 0 is f evaluated at g of 0. G of 0 is 0. F of 0 is radical 5. Let me do problem number 7. F of x is equal to x squared minus 8x plus 8. G of x is radical x. Compute f composed with g at 25. G of 25 is equal to the square root of x. Square root of 25 is 5. F at 5 is x squared minus 8x plus 8. 5 squared is 25. 8 times 5 is 40 plus 8 is 33. Negative 7. And so I have that f composed with g at 25 is negative 7. Well, is f evaluated at g of 25, and g of 25 is 5, and f of 5 is negative 7. So now let me go down to a regular normal pace. So let me do problem number 8. So this is the first time we've done problem 8. So f of x is equal to 6x squared plus 5x. G of x is equal to 2x. I want to find f composed with g at x. To find f composed with g at x, wherever I see an x in the formula for f, I'm going to replace every x by the formula given by g. So wherever I see an x here in the formula for f, I'll replace x by 2 of x. And so this is equal to 6, replace x by 2 of x, plus 5, replace x by 2 of x. And so 2x quantity squared is 4x squared. 2 times 5x is 10x. 6 times 4 is 24x squared plus 10x. That is f composed with g at x. Any questions about that? Okay. Let me do problem number 9. Sure. No, thank you. Okay. Let me do problem number 9. F of x is equal to negative 4x plus 7. G of x is equal to 5x plus 4. I want to find number 9, g composed with f at x. So to evaluate g composed with f at x, wherever I see an x in the formula for g, I replace x by the formula given by f. So wherever I see an x here in g, I'm going to replace x by negative 4x plus 7. So wherever I see an x in the formula for g, I'm going to replace x by negative 4x plus 7. Multiply 5 inside the parentheses. So by distributive property, I have negative 20x plus 35 plus 4. And so g composed with f at x is a negative 20x plus 39. And that is your answer. Let me do problem number 10. F of x is equal to rad x plus 2. G of x equals 8x minus 6. I want to find f composed with g at x. So wherever I see an x in the formula for f, I'm going to replace every x in the formula for f by the formula given by g. So wherever I see an x here, I'm going to replace x by 8x minus 6. So this is equal to the square root of, replace x by 8x minus 6 plus 2. And so f composed with g at x is just the square root of 8x. 2 minus 6 is a negative 4. And that is your answer. Let me do problem number 11. F of x equal x cubed plus 4. Find the inverse of this one-to-one function. So I want to compute its, I want to calculate its inverse. I want to find the rule, the formula for the inverse. So to do that, my first step is to write f of x as y. Then interchange x and y. So wherever I see a y, I replace y by x. Wherever I see an x, I replace x by y. And now solve for y. Subtract 4 from both sides of my equation to isolate y on one side of my equation. Now to compute, to solve for y, let me take the cube root of both sides of my equation. Since the cube root is a one-to-one function, it's injective. I have that I can just take the cube root of both sides of the equation. Therefore, y is equal to the cube root of x minus 4. Now, the last step is to write it as an inverse function. So instead of writing y, I'll write it as f, because that's the name of the function. Inverse of x is cube root x minus 4. And that is your answer. Let me do problem number 12. F of x equals the cube root of x minus 5. So again, I want to find the inverse function. So let's write f of x as y. Let's interchange x and y. Let's solve for y. So let me cube both sides of my equation. And again, the cube is a injective function. So I have that x cubed is equal to y minus 5. Let's add 5 to both sides of my equation. And so y is equal to x cubed plus 5. And again, let's write this as an inverse function. So it's f inverse of x is x cubed plus 5. So that's the formula for my function, my inverse function. Let me do problem number 13. F of x is equal to x plus 7 cube minus 4. Oops, sorry, plus 4. Okay, so let me determine the inverse function for this. Let me write f of x as y. Let me interchange x and y. Let me isolate y on one side of my equation. So let me subtract 4 from both sides of my equation. So I get that x minus 4 is y plus 7 cube. Let's take the cube root of both sides of my equation. The cube root is injective, so I have that the cube root of x minus 4 is equal to y plus 7. Let's subtract 7 from both sides of my equation. So I get that y is equal to the cube root of x minus 4 minus 7. And again, let's write this as an inverse function. So f inverse of x is the cube root of x minus 4 minus 7. And that is the inverse function for my original function. Let me wait a second just to be sure that I haven't passed everyone. So let me wait 1 second here. Okay, now let me go to problem number 14. Three to the 4x is equal to 1 over 243. Solve the equation. So either we can do it with logarithms or just change everything to a common base. In this case, there is a common base, so let me just use the common base. And so 3 to the 4x is equal to 243 is 3 to the power 5. Therefore, 1 over 243 is 3 to the power negative 5. And so, let me, since the exponential function is injective, since the bases are equal, then the exponents must be equal. Let me divide both sides of my equation by 4. And so x is equal to a negative 5 over 4. And that is your answer. Let me do problem number 15. Nine x equals 1 over 243. Okay. Again, I could do this if I wanted to, but with logarithms, but I don't want to. It's much easier if I use just a common base. The common base in this case is 3. And so 9 is 3 squared. 1 over 243 is 3 to the negative 5. And so I have that 3 to the 2x is equal to 3 to the negative 5. Since the exponential function is 1 to 1, injective, since the bases are equal, then the exponents must be equal. So 2x must equal negative 5, divide by 2. So x is equal to a negative 5 over 2. Let me do problem number 16. Again, this is 4 to the power 3x minus 7 is equal to 16. I can find a common base. I'll do base 4. 16 is 4 squared. Since the exponential function is injective, since the quantities are equal and the bases are equal, then the exponents must be equal. So therefore 3x minus 7 is equal to 2. Add 7 to both sides of your equation. Divide by 3. And so x is equal to 3. Let me do problem number 17. Uh, 4 to the 5 plus 3x is equal to 1 over 256. Okay. And so let's do a common base. So I have 4 to the power 5 plus 3x is equal to, well, 4 to the power 4 is 256. Therefore, 4 to the power negative 4 is equal to 1 over 256. Since the exponential function is injective, since the quantities are equal, since the bases are equal, then the exponents must be equal. Therefore, 5 plus 3x is equal to negative 4. Subtract 5 from both sides of your equation. Divide by 3. So x is equal to negative 3. Let me do problem number 18. Eight to the 5x minus 1 is 16 to the 4x. Well, the common base here will be 2. 2 cubed is 8. to the fourth is 16. And so a base to a power, well, to calculate that, you keep the base and multiply exponents. So 3 times 5x is 15x. 3 times 1 is 3. 4 times 4x is 16x. Since the quantities are equal, since the bases are equal, and since this is a injective function, since the exponential function is an injective function, then the exponents must be equal. Subtract 15x from both sides of your equation. So I get that x is equal to negative 3. Let me do problem number 19. Log base a m minus log base a n plus 3 log base a k. Express as the logarithm of a single expression. Assume the variables represent positive numbers. Okay. And of course, that the base is not equal to 1. So assume that also that the base is positive and not equal to 1, and that the variables are positive. They forgot. We always assume that about the bases. They forgot to tell you that that's just an implicit assumption that the bases are greater than 0 and not equal to 1. Okay, so let's write this as a single logarithm. Notice that each of these are log base a. M is a positive quantity. There's a positive number in front of m, and so m is in the numerator. N is in the denominator because it's a negative in front of the log. K will be in the numerator since it's a positive number in front of the log. And the exponent will be 3 since there's a 3 out in front of the log. And this is my answer. So it's a log base a of mk cubed divided by n. Let me do problem number 20. Log base 3 x minus 4 minus log base 3 x plus 6. So this will equal the log base 3 of, well, in the numerator will be x minus 4, in the denominator x plus 6. Since there is a plus in front of the log for the x minus 4, and there's a minus for the log of the x plus 6. Let me do problem number 21. 3 log base x of 3 plus log base x of 2. So this is a log base x of 3 cubed plus log base x of 2. 3 cubed is 27. Since I'm adding, I'll take the log of the product, 27 times 2. And so this is the log base x of 54. Let me do problem number 22. 5 log base 4 of x plus 1/8 log base 4 of x minus 4 log base 4 of x plus 7. So this is equal to the log base 4 of, well, the x is in the numerator because there's a plus in front of this log, and the exponent will be 5. There's a plus in front of this x, so this x will be in the numerator. And I have an exponent of 1/8. Well, an exponent of 1/8 is the same as the 8th root. And I'll leave it like that because rather than adding 5 plus 1/8, usually we write it so that we have x to some integer power times the root, the radical of x, where that exponent inside the radical is less than the index of the radical. So minus, therefore the x plus 7 will be in the denominator, and I have an exponent of 4. And that is your answer. Let me do problem number 23. Write the expression as sums or differences of multiples of logarithms. So basically do the opposite of what I just did. So log base 5 of x cubed over y to the 6th. So this is equal to, since x is in the numerator, I'll put a plus in front of the log of x. Since the exponent is 3, I'll bring the 3 out in front. Since the y is in the denominator, I'll subtract the log of y. Since the exponent of y is 6, I'll bring the 6 out in front. And that is your answer. So we just went in the opposite direction of the previous problems. Let me do problem number 24. Log base 4 of x plus 5 over x cubed. So this is equal to, since the x plus 5 is in the numerator, I'll put a plus in front of the x plus 5, the log of x plus 5. Since the x cubed is in the denominator, I'll subtract the log base 4 of x. Since the exponent of x is 3, I'll bring the 3 out in front. And that is your answer. Let me do problem number 25. This is the log base 4 of rad 5x. So this is the same as the log base 4 of 5x to the power 1/2. The square root is the same as an exponent of 1/2. I'll bring the exponent out in front of the logarithm. So this is equal to 1/2 the log base 4 of 5x. And, well, I can write this as 1/2 of the log base 4 of 5. Log base 4 of 5 plus the log base 4 of x. Since the log of a product is the sum of their logs, and, well, I can multiply each of these by 1/2. So this is 1/2 log base 4 of 5 plus 1/2 log base 4 of x. And that is your answer. Let me do problem number 26. 2 to the power x plus 7 equals 6. Okay, so in this case, we don't have any. So it says, solve the equation, give an exact solution. Okay, so in this case, we don't have any choice. We must use logarithms because there's no common base. And so let's take the log of both sides of my equation. And I will take the natural log of both sides of my equation. Please note that if you wrote that, it is wrong. Your teacher's going to take out points, and they're probably going to take out severe points. So notice it's always ln of 6. So you can't say, you take ln. Sometimes students write this. They go ln of this side and ln of that side. No, no, no. Don't ever write that. Ln has to be in front. You can't have ln of nothing. It has to be ln of something. It has to be a log of something. Okay, so this is equal to. Notice I have an exponent of x plus 7. So let's bring that x plus 7 out in front of the logarithm. Now, let me multiply the log 2 inside the parentheses. And so this is equal to x ln 2 plus 7 ln 2 is ln 6. So let me solve for x. So let me just subtract 7 ln 2 from both sides of my equation. And so I have that x ln 2 is equal to ln 6 minus 7 ln 2. Let me divide both sides of my equation by ln 2. And so I have that x is equal to ln 6 minus 7 ln 2 divided by ln 2. And that is your answer. Let me do problem number 27. E to the power 3x is equal to 8. So again, let me take ln of both sides of my equation. So I have e to 3x is equal to 8. So let me take ln of both sides of my equation. Ln e to any exponent is just the exponent. So ln e to the 3x is just 3x, using the fact that e and ln are inverse functions of each other. The exponential function of base e and ln are inverse functions of each other. Let me divide both sides of my equation by 3. So x is equal to ln 2, but ln (8) divided by 3. Let me just see, let me look in the back of the answers, because you can also simplify this to ln 2, but let me see what they did. This is problem number 27. They wrote it the same way. I hate that. Okay, but I will resist simplifying this. Okay. Oh, didn't you know for 26 they divided by ln of 2? I just noticed here. This is the same as ln of 2, ln of 6 over ln 2 minus 7 ln 2 over ln 2. So the ln 2's cancel. So you get ln 6 over ln 2 minus 7. So they wrote it this way. It's the same answer, obviously. Okay. Let me do problem number 28. E to the x plus 2 is equal to 4. Okay, so let me take ln of both sides of my equation. So I'll take ln of both sides of my equation. Ln e to the x plus 2 is again just x plus 2. Since the exponential function base e is the inverse function of the natural logarithm. So this is equal to ln 4. Subtract 2 from both sides of my equation. And so x is equal to ln 4 minus 2. Maybe I'll put parentheses there so you can see that you evaluate the ln 4 first. And that is your answer. Let me do problem number 29. Solve the equation log, so this is a common logarithm, 4x equals log 5 plus log x minus 3. So the log of 4x is equal to, since the sum of logs is equal to the log of their products, this is equal to log of 5 times x minus 3 is 5x minus 15. Since the logarithm is an injective function and these logs are equal and these logs have the same base, then the quantity inside the logarithms must be equal. Let me subtract 5x from both sides of my equation. And let me divide both sides of my equation by negative 1. So x is equal to 15. Now, 4 times 15 is positive. 5 is positive. 15 minus 3 is positive. Therefore, x equaling 15 is a solution. You always have to check that you don't have an extraneous solution due to the fact that you're taking the log of a negative quantity or a non-positive quantity. Let me do problem number 30. Log x plus 4 equals log 5x minus 5. Since these logarithms are equal, and since the logarithms have the same base, and since the logarithmic function is injective, then the quantity inside the logarithms must be equal. Subtract x, add 5 to both sides of your equation to isolate x on one side of your equation. And so 9 is equal to 4x. Divide both sides of your equation by 4. So x is equal to 9 over 4. Well, 9 over 4 plus 4 is a positive quantity. 9 over 5 times 9 over 4 minus 5 is also a positive quantity. Therefore, x is equal to 9 over 4. This is not an extraneous solution. Let me do problem number 31. log base 2 of x is equal to 5. Well, in this case, the base is 2, the exponent is 5, and the result is x. And so x is equal to 2 to the power 5, 32. 32 is a positive quantity, so I can take the log of 32. Therefore, x is equal to 32. Let me do problem number 32. Log, the common logarithm, of 4 plus x minus the log of x minus 4 is equal to the log of 3. And so, since the difference of logs is the log of their quotient, this is the same as 4 plus x over x minus 4 is equal to the log of 3. And so, since the logarithms are equal, since the bases are equal, since the logarithmic function is injective, then what's inside the logarithms must be equal. Let me write 4 plus x as x plus 4, just so it looks nicer. And this is therefore equal to 3. Let me write 3 is 3 over 1, and let me cross multiply. And so I have that 3x minus 12 is equal to x plus 4. Subtract x, add 12 to both sides of your equation. And so 2x is equal to 16. Divide both sides of the equation by 2. So x is equal to 8. Since 4 plus 8 is positive, 8 minus 4 is positive, and 3 is positive, then x is equal to 8. Any questions? Okay. Let me do problem 33. Log base 4, 7, log base 4x is equal to 1. Please bring back 32. Okay. Wait a second. Sorry about that. Okay. I assume that means you're done. Okay. So problem number 33. So since I have the sum of logs, that's the same as the log of their product. So this is log base 4 of 7x is equal to 1. Let me rewrite this logarithmic form in an exponential form. The base is 4, exponent is 1, result is 7x. So 7x is equal to 4. Divide both sides of your equation by 7. And so x is equal to 4 over 7. Since 7 is 32, bring it back. Sorry. I thought you were done. Sorry about that. I'm sorry, got overly excited. I thought you guys were done with that. Now you're done, I think, right? Whoa. No. Tell me when you're done so I don't scroll back the incorrect time. When you're done, just click, and I'll scroll back up. Okay. Done. Sorry about that. I guess I must have really gone ahead of people. Okay, so um, I guess I'll take a little while longer to do this then. Since 7 is positive, and since 4 over 7 is positive, then x is equal to 4 over 7. Let me rest my hand for a second while you guys catch up. And then I'll start in about 10 seconds. Okay, so problem number 34. ln 8 plus ln x is 0. The sum of logarithms is the same as the log of their product. Therefore, this is the same as a log ln of 8x is equal to 0. So let me rewrite this logarithmic form in exponential form. The base is e because this is a natural logarithm. So the base is understood to be e, the exponent is 0, and the result is 8x. E to the power 0 is 1. Divide both sides of your equation by 8. So x is equal to 1 over 8. Since 8 is greater than 0, since 1 over 8 is greater than 0, I can take the log of each of those. Therefore, x equaling 1/8 is an actual answer. It's not an extraneous solution. Okay. Let me do problem number 35. Log base 4 x squared minus 3x is equal to 1. So again, let's rewrite this logarithmic form in exponential form. The base is 4, the exponent is 1, and the result is x squared minus 3x. Well, 4 to the power 1 is just 4, so let me subtract 4 from both sides of my equation. So I get x squared minus 3x minus 4 is 0. Well, this is a nice monic quadratic trinomial. So let's try to factor this. So this is going to factor as x. I have a negative, so I'll bring down the negative. Negative times negative is positive. I want two whole numbers whose product is 4 and whose difference is 3. Well, 4 and 1. And I'll take the number with the factor with the large absolute value and put that first. And so, by the zero factor property, the fact that this is a integral, that this polynomial is an integral domain, I have that x minus 4 is 0 or x plus 1 is 0. Add 4 to both sides of my equation. So x is equal to positive 4. Subtract 1 from both sides of my equation, so x is negative 1. Let's plug in 4. 4 squared is 16, minus 3 times 4, 12 is 4. Good. So I can take the log of a positive quantity. Let's plug in -1. -1 squared is 1. -3 times -1 is +3, plus 1 is 4. Again, I can take the log of a positive quantity. So x is equal to two answers, -1, and it's also equal to +4. So in this case, we actually have two answers that work. So two solutions to this logarithmic equation. Let me do problem number 36. Log base 5 of x plus log base 5 x minus 24 is equal to 2. Okay, so I know that the sum of logs is the same as the log of their product, and so this is the same as the log base 5 of x multiplied by the x minus 24 is x squared minus 24x is equal to 2. So now I have a logarithmic form. Let's write that as in exponential form. And so the base is 5, the exponent is 2, and the result is x squared minus 24x. Well, 5 squared is 25. Subtract 25 from both sides of my equation. So I get x squared minus 24x minus 25 is 0. Factor. Again, this is a monic quadratic trinomial in x. So I put x's here. I have a minus, so I'll bring down the minus. Times minus is plus. I want to find two whole numbers whose product is 25 and whose difference is 24. Well, 25 times 1 is 25. 25 minus 1 is 24. And I put the number with the larger absolute value first. And so by the zero factor property, I set each factor equal to 0 and solve for x. Add 25 to both sides of your equation to solve for x. So x is equal to 25. Subtract 1 from both sides of my equation. So x is equal to -1. And now let's check if any of these answers are extraneous. Well, I can take the log of 25. 25 is positive. I can take the log of, well, 25 minus 24 is 1. So that's a positive quantity. So they're logs of positive quantities. I can take the log of each of those. That's fine. -1. The log of -1, can't do that. So that's not a solution. So in this case, I only have one solution, 25. So be sure that you check to see that you're not taking the log of a negative quantity, and be sure that you check in the original equation that you're not taking the log of a non-positive quantity in the original equation. If you do, then you've got to get rid of those non-positive, the logs of those non-positive quantities. Those will not be solutions to the original equation. Let me wait 1 second to be sure that I didn't go too far ahead. We are fine. Okay. Okay, good. Let me do problem number 37. Oops. Let me do problem 37. x minus 4 squared plus y squared equals 16. Sketch the graph of the equation. If the graph is a parabola, find the vertex. If the graph is a circle, find the center and radius. Okay. Well, first notice that I have both x squared and y squared, and they're both of the same sign. So that means either it's going to be an ellipse or a circle. Since the quantities in front of x squared and y squared are the same, then it is a special type of ellipse. It is a circle. So this is a circle. The center of this circle is going to be, well, when x minus 4 is 0, so when x is 4, and when y is 0. The radius of this circle will be, well, the square root of 16, which is 4. Okay, so let's try to, as best I can, try to draw the graph of this circle. Well, make it a little bit bigger. One, two, three, 4. 2, 3, 4. 2, 3, 4. 4. Okay. The center of this circle was at 4, 0. The radius is 4. So you go out 4 in the x, 4 in the y, from the center. And let's see if I can do this. So it's really a big circle. I am going to try as best I can to make it look like a circle. It's not happening. Oh, this is horrible. Okay, that's just horrible. Okay, let me try that. Let me get into a different position. Let's see. Let's try a different position. Okay, just use your imagination. So that is a circle of radius 4. So it's a circle, and the radius is 4, and the center is at 4, 0. Yeah. Okay, so just, as I say, just draw it as best you can. Okay, so let's do problem number 38. Okay, so x minus 4 squared, y plus 4 squared equals 16. Again, you have both an x squared and a y squared term. They're both of the same sign, so it's an ellipse. They're both equal constants in front of the x squared and y squared. So it's a special ellipse, a circle. The center of the circle, found by setting x minus 4 to 0, y plus 4 to 0, is 4, negative 4. And again, the radius is 4. So again, a big circle. So I'm going to try best as I can to draw a big circle. It's not so easy on this, but I'll try as best I can. I can't even draw a straight line. Okay. So you just have to use your imagination. Yeah, it's the same one. Well, it'll just take me a second to graph this. So 1, 2, 3, 4. Uh-oh. 1, 2, 3, 4. Except that it's going to go much further down. 5, 5, 6, 7, 8. Okay, so the center is going to be at 4. 1, 2, 3, 4. 2, 3, 4. So the center is at 4, negative 4. Has a radius of 4. And you draw your circle as best you can at center 4, negative 4. And that's your answer. Let me do problem number 39. Write an equation of the circle who's with the given center 2, 10 and radius 3. So the equation of a circle is x minus h squared plus y minus k squared equals r squared. So this is h, k. So the equation is x minus 2 squared, y minus 10 squared equals 3 squared, 9. That is the equation of your circle. Problem 40. The center is at 0, 7. The radius is 6. Therefore, the equation is x minus 0 squared plus y minus 7 squared equals 6 squared, 36. 41. The center is at negative 5, 10. The radius is rad 10. Oh, that makes a little bit of difference for students. Or x minus 2. So it's x minus h quantity squared. That is correct. So that's why it's minus 2. 41. So again, it's x minus h minus a negative 5 is a plus 5. Y minus k, so y minus 10 quantity squared equals r squared. The square root of 10 squared is 10. And that is your answer. So that's actually kind of nice. So it should answer some of your questions by just looking at that one. For 40, but why did you write just x squared? Oh, because it's x minus 0 squared. So x minus 0 is just x squared, because that's a 0 there. Okay? So, I mean, you could write x minus 0 squared, but we usually don't. We just usually write x squared. Let me do problem number 42. X squared plus y squared minus 10x plus 2y plus 16 equals 0. Find the center and radius of the circle. So in this case, you're going to have to complete the square. So this is x squared minus 10x plus y squared plus 2y equals, subtracting 16 from both sides, negative 16. So I just wrote the x's together, the y's together. So now let's fill this in. since there is this is a monic quadratic, since there's a 1 in front of the x squared, then to complete the square, you just do negative 10 divided by 2. Negative 10 divided by 2 is a negative 5. Negative 5 squared is 25. So you add 25 to both sides of your equation. Since this equation for the y is also a monic quadratic, then to complete the square, I do 2 divided by 2, 1. 1 squared is 1. And so, I get that 25 plus 1 is 26 minus 16 is 10. And so I have x minus 5 squared plus y plus 1 squared is 10. Find the center and radius. Aha. So now let's find the center. The center of the circle, well, found by setting x minus 5 to 0. So x is 5. Y plus 1 to 0. So y is negative 1. And the radius is just the square root of the 10. So radical 10. And that is your answer. Let me do problem number 43. X squared plus y squared minus 4x minus 8y plus 11 equals 0. Sketch the graph of the equation. If the graph is a parabola, find its vertex. If the graph is a circle, find its center and radius. They always give you circles. What is this? Okay, so I have an x squared and a y squared term. Therefore, it's an ellipse, and they're both positive. So it's an ellipse. And since both of the quantities in front of the x squared and y squared are equal, it's a special ellipse called a circle. So this is the case of a circle. Let's complete the square to put this into the standard form for the equation of a circle. So I have x squared minus 4x grouping all the x's together plus y squared minus 8y, subtracting 11 from both sides, is equal to negative 11. Yes. How do we figure out it's a circle? Easy. If it had x squared and y squared, if these numbers, so I only look at these squares. If both these numbers are the same, circle. So let's say that that's a 5 and a 5, circle. If they're both of the same sign, but it's, you know, they're not the same numbers, ellipse. If they're differing signs, hyperbola. If there's only one square term, parabola. So I just looked and I said, oh, look, there's an x squared, there's a y squared, circle. Well, actually, there's an x squared and there's a positive x squared, there's a positive y squared. I know it's an ellipse, but since they're equal, then I know it's a circle. There's a special ellipse. Okay? Answer your question? Okay, good. So that's an easy way to figure out what everything is. Okay, so now since there's a 1 in front of the x squared, to complete the square, I do negative 4 divided by 2 is a negative 2. Negative 2 squared is 4. So let's add 4 to both sides of my equation. Since there's a 1 in front of the y squared, to complete the square, I do negative 8 divided by 2, negative 4. Negative 4 squared, 16. So let me add 16 to both sides of my equation. And so 16 plus 4 is 20, minus 11 is 9. Is 9. Okay, so it says sketch the graph and find its center and radius. Okay, so the center of the circle found by setting x minus 2 to 0 is 2. The y-coordinate of the center is found by setting y minus 4 to 0, 4. The radius is just the square root of 9, 3. So that's the center and radius. And I'm going to try as best I can. 2, 4. Well, that's way up there, isn't it? Okay. 1, 2, 3, 4, 5, 6, 7. Good. Okay. X. Oh, I don't even need that far. Okay. So 1, 2, 3, 4, 5. And I'm here at 1, 2, 3, 4, 5. Okay, so the center is at 2, 4. And I have to go up 3. 1, 2, 3. So that's 7, and that's 1. So the center is at 2, 4, and the radius is 3. So I got 3, 3 from the center, and try best I can. It's a little bit smaller, so it should be a little easier. Yeah, I missed it, but it's just there. Just make the dots a little bit bigger, and therefore you got it. Okay, so the center is at 2, 4, and the radius is 3. And that's the graph of that circle. Let me do problem number 44. X squared plus y squared plus 8x plus 12y plus 48 is 0. Again, this will be the graph of a circle. I have both an x squared and y squared term. They're both of the same sign, so it's an ellipse. They're both equal. The quantities in front of x squared and y squared are both equal. Therefore, it is a circle. And so, let me complete the square to put this into standard form. So I have x squared, grouping all the x together, y squared plus 12y, grouping all the y's together, and bringing the constant to the other side of my equation, equals negative 48. Okay, so I have the following. So to complete my square, since there's a 1 in front of the x squared, 8 divided by 2 is 4. So let's add 4. 4 squared is 16. Just add 16 to both sides of my equation. Ooh, since there's a 1 in front of the y squared, to complete the square, I'll do 12 divided by 2 is 6. 6 squared is 36. Let me add 36 to both sides of my equation. And so 36 plus 16 is 52, minus 48 is 4. So the center of my circle, changing the sign, is negative 4, negative 6, and the radius of my circle is the square root of 4, 2. Well, at least the radius is small. So I should be able to do that. Okay, so 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8. Good. 1, 2, 3, 4, 5, 6. And so the center is at 1, 2, 3, 4, 5, 6. The negative 4, negative 6. The radius is 2. So you go 2 in the x, 2 in the y, and the radius is 2. Good. Actually, it looks a little bit better because it's smaller. Good. And so the center is negative 4, negative 6, and the radius is 2. And that is my graph of my circle. 45. Oh, that's a ellipse. So let me do problem number 45. Nine x squared plus 25y squared is 225. Graph the equation. Well, both the signs are the same for the x squared and y squared. Therefore, this is an ellipse. Divide both sides of your equation by 225. And so, okay. And so, I get the following. I get x squared over 25 plus y squared over 9 is equal to 1. Okay, so let's draw this. So the center, so first off, I notice that this is an ellipse. Okay, next, I notice that the center of this ellipse is at the origin. And I notice that A is the square root of 25, 5, and B, actually, let me put the A's and B's here, that A, square root of 25 is 5, and B, the square root of 9 is 3. So let me draw this. The center is at the origin. Okay, and so let's draw this. So I'll go 1, 2, 3 in the Y. Actually, let me just put the 3's here. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let me try to draw this ellipse. Oh, I had it. Not bad. Okay, so that's my ellipse. Okay, and so the center is at 0, 0. You go a distance of 5 in the x to get from the center to get to your vertex, and you go a distance of 3 in the y direction from the center to get to your other vertex. Let me do problem number 46. yet another ellipse. 25 x squared plus 16 y squared is equal to 400. Okay, so let's divide. Well, first off, I notice it's an ellipse because both the x squared and y squared terms have the same sign. They're both positive. And so this is an ellipse. Let me divide both sides of my equation by 400 to put this into standard form. So I get x squared over 16 plus y squared over 25 is 1. Okay. So I have that this is an ellipse. I have that the center is at the origin. I have that A is equal to square root of 16, 4. B, the square root of 25 is 5. Okay, so let's do this. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so here are my vertices. It's bigger, so it's going to be harder to draw. I'll try best I can. Yeah, whatever. Okay, so this is the center is at the origin. So this would be 4 minus 4 minus 5, 5. So you go 4 in the x direction, since that's A, and 5 in the y direction from the center to get to your vertices. And that's what your ellipse looks like. Let me do problem number 47. That's going to be a hyperbola. Y squared over 9 minus x squared over 36 is 1. Well, since you have both x squared and y squared, and since they're of differing signs, I know that this is a hyperbola. So this is a hyperbola. I know that the center is at the origin. A, square root of 36 is 6. B, square root of 9, 3. Okay, and so let's draw this. Again, as best I can. Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So let me draw my bounding rectangle. Okay, good. And let me draw my asymptotes, the diagonal of these bounding rectangle. Oops. Let's try again. Come on. Okay. Let's try again. Good enough. Not really a straight line, but not really a straight line. And I missed the corner. Okay, good enough. Good enough for my lines, as best I can do. And notice that y squared is positive. So that means that the vertices are going to be located along the y-axis at 3 and negative 3. The center is going to be at the origin. And let me try to draw. This is really big. Try to draw this as best I can. So I'm going to start here at the vertex, slowly approach. Oh, that's horrible. The asymptotes. Oh, that's just really horrible. And let's try this side. So, wow. It just doesn't want to go in the same direction that I go in. Okay, so this. Oh, that's just horrible. Okay. Oh, come on. Okay, so this is the best I can do. So that's the hyperbola and the asymptotes, approaching the asymptotes. Okay. Obviously, well, this side is really bad. Let me at least... Yeah, that doesn't even look like hyperbola at all. Let's at least get a little bit better. Okay. It's as best as I can do. So that's your hyperbola. Let me do problem number 48, another hyperbola. 4y squared minus 9x squared equals 36. So let's divide. Again, this is going to be a hyperbola because I have both x squared and y squared, and they're of differing signs. Divide both sides of my equation by 36. So I get y squared over 9 minus x squared over 4 is equal to 1. So the center of my hyperbola will be at 0, 0. Oh, I should see. They just asked me to sketch, right? Yeah, just graph. Okay. The a in this case, square root of 4 is 2. The b in this case, square root of 9 is 3. So that's not too horribly big. So let me try to sketch this. Okay, so 1, 2, 1, 2 at the x, 1, 2, 3, 1, 2, 3 in the y. Let me draw the bounding rectangle. Let me draw the asymptotes. Well, that's not going to go too far since I don't have very far to go. That direction. And so the square is positive in front of the y. And so my Vertices are here. This is my center. And here are my vertices. And let's draw the asymptote. Let's draw the Let's draw. Not too bad. The hyperbola approaching the asymptote. Not too bad. But this is not going to look good on this side. Well, okay, good enough. So that is my hyperbola, as best I can draw it. 49. Solve the nonlinear system of equations for real solutions. X squared plus y squared equals 58. 7x plus 3y equals 0. Okay, so let me call this R1, and let me call this R2. So I have a circle and a line, so you can either have 0, 1, or 2 solutions for a circle intersecting a line. Let me use substitution. So let me solve for, I don't care, x, no, solve for y. So let me use R2 to solve for y. So I have 7x plus 3y is 0. Subtract 7x from both sides of your equation. And so 3y is equal to negative 7x. Divide both sides of your equation by 3. And so y is equal to negative 7/3 x. And so let me plug that into and so let me call this S1. So now let me plug S1 into R1. So let's substitute for y into in R1 using S1. And so I have x squared plus y squared is 58. Oopsie daisy. Let's see. What is S1? I'm just calling it the equation y equal negative 7/3 x, because I'm going to have to refer to it in the future. So I just called, so this equation here. So let me do R1, or let's plug S1 into R1. And so I get x squared plus y squared equals 58, where I've substituted for y negative 7/3 x. And so let me simplify this. So I get x squared plus a negative 7 squared is 49. 3 squared is 9. X squared equals 58. Let me multiply both sides of my equation by 9 to get rid of the fraction. So I get 9x squared plus 49x squared is 522, is 9 times 58, because that's going to be a 58. And so I get 58 x squared is 522. Divide both sides of the equation by 58. So x squared is 9. Uh, 522 divided by 58 is 9, yes. Okay. And now from this I get x is equal to plus or minus 3. And let's figure out what y is. So when x is 3, let's say negative 3, let's figure out y. When x is positive 3, let's figure out y. So let's use S1, that's what I was going to refer to it, as negative 7/3 x. So y equals negative 7/3 x. So y is equal to positive 7. And so a point of intersection is negative 3, 7. Okay, that's one solution. Let's look at the other solution. So let's look what happens when x is 3. So again, S1 says that y equals negative 7/3 x. The 3's cancel, so y equals negative 7. Therefore, the other point of intersection is 3, negative 7. And so I have 2 points of intersection. And so, good. That's what I expected. I expected 0, 1, or 2 solutions. I have 2 solutions. Let me do problem number 50. X squared minus 7y squared equals negative 54. Let's call that R1. Y equals x, so let's call that R2. Okay, so again, I've got well, actually, in this case, I have a hyperbola and a line. So hyperbola and a line can intersect at 0, 1, 2, 3, or 4 points. And so either 0, 1, 2, 3, or 4. A number of solutions. And so, again, let's use substitution. So I've already solved for y in terms of x. That's R2, so let's plug R2 into R1. So R2 plugging into R1 says that x squared minus 7y squared, but y is just x, is equal to negative 54. Well, x squared minus 7x squared is a negative 6, x squared. So let me divide both sides of my equation by 6, negative 6, sorry. And so x squared is equal to 9. And so x is equal to plus or minus 3. In this case, it's actually pretty easy to plug in. So when x is negative 3, when x is 3, well, I'll plug in R2. Y is just equal to x. Y is just equal to x. Therefore, the point of intersection is negative 3, negative 3, positive 3, positive 3. So there are 2 solutions to this system of nonlinear equations. Let me do problem number 51. X squared plus y squared is 41. I'll call that R1. R2, x plus y equals 9. So this is a circle and a line. So a circle and a line can intersect at 0, 1, or 2 points. I guess I'll use substitution yet again. So let's solve R2 for y. So let's just subtract x from both sides of my equation. So y is equal to 9 minus x. Again, I guess I'll call that S1. And now let's use S1 to substitute for y in R1. And so let's plug S1 into R1. And so if I do that, I get x squared plus y, 9 minus x squared, equals 41. Let's simplify this. So I get x squared plus 9 minus x quantity squared by the special product formula is just 81 minus 18x plus x squared is 41. Combine like terms, so I get 2x squared minus 18x plus 81 is 41. Subtract 41 from both sides of your equation. So I have 2x squared minus 18x plus 40 is 0. Let me divide every term by 2. So I get x squared minus 9x plus 20 is 0. So let me try to factor this. So again, this is a monic trinomial quadratic in x. And so I'll just put x's here. I have a minus. So I'll drop down the minus times plus is minus. I want two whole numbers whose product is 20 and whose sum is 9. 5 times 4 is 20. 5 plus 4 is 9. And I put the factor with the larger absolute value first. Set each factor to 0 and solve for x by the zero factor property. Add 5 to both sides of your equation. And so x is equal to 5. X is equal to 4. Adding 4 to both sides of your equation. And now let's try to figure out, well, what y is. Well, y, I'll use S1. Y is equal to x, no, 9 minus x. Y is equal to 9 minus x. Y is equal to 9 minus x. And so, one point of intersection is 5, 4. The other one is 4, 5. That's nice and symmetric. And so those are my two points of intersection between these two nonlinear, well, between these this nonlinear system of equations. Let me do problem number 52. X squared plus y squared is 74. Let me call that R1. R2, 52, right? X squared minus y squared is 24. So let's just add these. So if I do that, I get 2x squared, the y squares cancel, equals 98. Divide both sides of the equation by 2. So x squared is 49. And so let's plug. So it says here that x is equal to plus or minus 7. let's plug 49, x squared equals 49, back into R1. So that says that 49 plus y squared is 74. Let's subtract 49 from both sides of my equation. So y squared is equal to 25. And so y is equal to plus or minus 5. And so when x is negative 7, y could be negative 5 or positive 5. When x is positive 7, y could be negative 5 or positive 5. And so I have 4 points of intersection between this, I should have said that, between this circle and hyperbola. So you could have had 0, 1, 2, 3, 4 points of intersection. In this case, we have 4 points of intersection between the circle and hyperbola. Let me do problem number 53. R1, 2x squared minus 5y squared equals negative 37. Hyperbola. R2, 2x squared minus 3 plus 3y squared ellipse equals 35. So you have a hyperbola and ellipse. Again, you could either have 0, 1, 2, 3, or 4 points of intersection between a hyperbola and an ellipse. Let's do negative R1 plus R2. So negative 2x squared plus 5y squared equals 37. 2x squared plus 3y squared equals 35. And so the 2x squares cancel. I get 8y squared is 72. Divide both sides of your equation by 8. I don't have enough room, but divide by 8. So I get that y squared is equal to 9. Therefore, y is plus or minus 3. Let's plug into R2. So I have 2x squared plus 3y squared, 9, equals 35. So 2x squared plus 27 is 35. Subtract 27 from both sides of my equation. So 2x squared equals 8. Divide by 2. So x squared is 4. So x is plus or minus 2. Therefore, when x is negative 2, y could be negative 3 or positive 3. When x is positive 2, y could be negative 3 or positive 3. And so I have 4 solutions to this system of nonlinear equations. Let me do problem 54. X squared minus y squared equals 5, a hyperbola. X squared plus y squared equals 31, circle. And so I have a circle and a hyperbola. They can intersect at 0, 1, 2, 3, or 4 points of intersection. Let's add these together. X squared plus x squared is 2x squared. 35 plus 31 is 36. The y squares cancel. Divide, both sides of the equation by 2. Yeah. And so I get x squared is equal to 18. So that says that x is equal to plus or minus the square root of 18. I can write 18 as 9 times 2. So x is equal to 3 rad 2. Let's plug into R2. So x squared plus y squared is 31. Subtract 18 from both sides of your equation. And so I get that y squared is equal to 13. And so y is equal to plus or minus the square root of 13. Okay, so I have that x, when x is negative 3 rad 2, y could be negative rad 13 or positive rad 13. When x is positive 3 rad 2, y could be negative rad 13 or y could be positive rad 13. So again, I have 4 solutions to this system of nonlinear equations. 55. 530. Okay. Oh, not too horribly bad. Okay, we might actually get through all this. So problem 55. Write the first 5 terms of the sequence whose general term is given. So a sub n is given as n minus 5. So I'm just going to plug in 1, 2, 3, 4, 5. So first 5 terms. So 1, 2, 3, 4, 5. And so this is just negative 4, negative 3, negative 2, negative 1, 0. That's the first 5 terms. Okay. So that is the first 5 terms of my sequence. Let me do problem number 56. A sub n is negative 3 to the power n. Okay. So a sub 1, negative 3. A sub 2, positive 9. A sub 3, negative 27. A sub 4, positive 81. A sub 5, negative 243. And so This sequence is -3, 9, -27, 81, -243, etc. So that's the first 5 terms. 57, an, n plus 1 over 2n minus 1. Okay, so a sub 1 is 1 plus 1 over 2 times 1 minus 1. So 2 over 2 minus 1 is 2. A sub 2. 2 plus 1 over 2 times 2 minus 1, which is 3 over 4 minus 1, 1. A sub 3. 3n plus 1 over 2n minus 1. So 3 plus, so 4 over 6 minus 1, 4 over 5. A sub 4, n plus 1 over 2n minus 1. So 5 over 8 minus 1, 5 over 7, and 5. N plus 1 over 2n minus 1. So 6 over 10 minus 1, 6 over 9, 2 over 3. Okay, so the sequence looks as follows. So 2, 1. So it's 2, 1, 4/5, 5/7, 2/3, etc. And that is your sequence. Problem number 58. A sub n is equal to -1 to the n plus 9. Okay, so a sub 1, -1 to the 1, 1 plus 9. -1 to the 1 is negative. 1 plus 9 is 10. A sub 2, -1 squared, 2 plus 9. Well, -1 squared is a plus 1. 2 plus 9 is 11. A sub 3, -1 cubed, n plus 9. -1 cubed is a negative. 3 plus 9 is 12. A sub 4, -1 to the n plus 9. A -1 to the 4 is positive. 4 plus 9 is 13. A sub 5, -1 to the 5, n plus 9. -1 to the 9, a -1 to the 5 is a negative. 5 plus 9 is 14. And so I have the following sequence: -10, 11, -12, 13, -14, etc. And that is my sequence. 59. So let me do problem number 59. A sub n is equal to 2, 2n minus 1. I want to figure out A25. Okay, so it says here that find the indicated term for the sequence whose general term is given. So I have that 2n, that a sub n is equal to 2 times 2n minus 1. And so this is equal to 2 times 50 minus 1, 2 times 49. And so a sub 25 is 98. Let me do problem number 60. A sub n is equal to 4 minus n squared. Determine a sub 3. Well, a sub n is equal to 4 minus n squared. So 4 minus 9 is a negative 5. 61. A sub n is 4n minus 1. Determine a sub 5. Well, a sub n is 4n minus 1. 4 times 5 is 20, minus 1 is 19. 62. A to the n is 3n. Determine a sub 4. Well, a sub n is 3 to the n. 3 to the 4th is 81. 63. A to the n is 1 over n squared. So a to the 7. I want to determine a to the a sub 7. Well, a sub n is 1 over n squared. 7 squared is 49. So a sub n is 1 over 49. Let's do problem number 64. A1 is 15. The common difference D is negative 3. Write the first 5 terms of the arithmetic sequence whose first term a sub 1 and common difference D are given. So the first term is 15, minus 3, 12, minus 3, 9, minus 3, 6, minus 3, 3, etc. So that is the first 5 terms of this arithmetic sequence. 65. Find the 8th term of an arithmetic sequence whose first term is negative 10 and whose common difference is negative 2. Well, I know the formula for the general term of an arithmetic sequence. The general term is just a1 plus n minus 1d. And so a sub 8 is equal to a sub 1, negative 10, plus n, 8 minus 1, times d, negative 2. And so a sub 8 is negative 10 plus 7 times negative 2. A sub 8 is negative 10 minus 14. A sub 8 is negative 24. Let me do problem number 66. Oh, okay, good. Just 2 more pages. So 66. The 11th term of the arithmetic sequence So I want to find the 11th term of an arithmetic sequence. Whose first term is -4 and whose common difference is -6. So the general term of an arithmetic sequence is just a sub n equals a1 plus n minus 1d. And so let's plug in for that. So the 11th term is just the first term, -4, plus n, which is 11, minus 1, times d, which is -6. And so a sub 11 is -4 plus 10 times -6, -64. Okay, so a sub 11 equals -4 minus 60, -64. Let me do problem number 67. Find the 12th term of an arithmetic sequence. -5, 1, 7, etc. And so the general term is just a1 of an arithmetic sequence is a sub 1 n minus 1d. And so the 12th term is just a sub 1. Well, a sub 1 in this case is -5 plus n in this case is 12 minus 1 times d. Well, the common difference to go from -5 to 1 add 6. To go from 1 to 7 add 6. The common difference is 6. So a sub 12 is -5 plus 11 times 6. So a sub 12 is a -5 plus 66. So a sub 12 is 50. Stupid. Is 61. And so a sub 12 is 61, if I can add correctly. Okay, so let me do problem number 68. Find the 12th term. Again, 68. Oh, I'm doing the wrong term. Find the 12th term, yes, of an arithmetic sequence. -5, 68, 68, 0, 6, 12. Okay. And so let's find the 12th term of that arithmetic sequence. Yes. Okay, so again, the general term for arithmetic sequence is a sub n is a sub 1 plus n minus 1d. And so the 12th term, a sub 12, is equal to the first term, 0, plus n, 12, minus 1, times d. Well, 0 plus 6 is 6, plus 6 is 12. So the common difference is 6. So a sub 12 is equal to 11 times 6, 66. Let me do 69. The 16th term, again, of an arithmetic sequence. Um, 30, 26, 22, etc. So the general term for arithmetic sequence is a sub n is a sub 1 plus n minus 1d. So the 16th term is a sub 1, 30, plus n, 16 minus 1, times the common difference. The common difference in this case is, well, 30 minus 4 is 26. Minus 4 is 22. And so the common difference is negative 4. 16 minus 1 is 15 times negative 4. Is equal to 30 minus 60, which is a negative 30. Let me do problem number 70. A sub 1 is 9. D is negative 1. Didn't we have a whole bunch like that? Yeah. Okay. Okay, so write the first 5 terms of the arithmetic sequence whose first term A1 and whose common difference D is given. And so let's write the first 5 terms. So 9 minus 1, 8, minus 1, 7, minus 1, 6, minus 1, 5. So that's the first 5 terms. 71. The first term is negative 22. The common difference is 3. And so let's write the first 5 terms. Negative 22 plus 3, negative 19 plus 3, negative 16 plus 3, negative 13 plus 3, negative 10. Etc. Let me do problem number 72. Nine, 14, 19. Okay, so given are the first 3 terms of an arithmetic sequence, of a sequence that is arithmetic. So this is arithmetic sequence. Find A1 and D. Well, the first term is 9. You add to 9 5 to get to 14, 5 to get to 19. Let me do problem number 73. Nine, 13, 17. Again, this is the arithmetic sequence. The first term is 9. You add to 9 4 to get to 13, 4 to get to 17. And so that's the first term and the common difference. 74. 3, 2, 1. Again, this is arithmetic. The first term is 3. The common difference is negative 1. Since 3 minus 1 is 2, minus 1 is 1, so the common difference is negative 1. 75. 0. Negative 3 halves. Negative 3. Again, this is arithmetic. The first term is 0. The common difference is negative 3 halves. 0 minus 3 halves is negative 3 halves. Minus 3 halves is negative 3. Let me do problem number 76. Find the indicated term of the sequence. Find the fifth term of a geometric sequence. Whose first term is 6 and whose common ratio is -4. Well, I have that the general term of a geometric sequence is a sub n is a sub 1 times r to the n minus 1 power. So a sub 5 is equal to a sub 1, 6, times -4 to the power 5 minus 1. And so I get here a to the 5 is 6 times -4 to the 4. And so 4 to the power 4 is 256 positive. And so times 6 is 1536. Let me do problem number 77. The sixth term of a geometric sequence whose first terms are 7, 35, 175, etc. Okay, so the general term for a geometric sequence is a sub n is a sub 1 r to the n minus 1. So to find a sub 6 is equal to a sub 1, which is 7, times r. Well, in this case, the common ratio is 5. 7 times 5 is 35, times 5, 175. The power 6 minus 1. And so a sub 6 equals 7 times 5 to the 5th. Well, 5 to the power 5 is 3125 times 7 is 21,875. So 21,875. Okay. Let me do problem number 78. Find the sixth term again of the geometric sequence whose terms are 7, -14, 28, etc. Okay. Again, the general term for a geometric sequence is given by a sub n is equal to a sub 1 r to the n minus 1. So a sub 6 is equal to a sub 1, where the first term is 7, times r. 7 times -2 is -14, times -2 is +28. So the common ratio is -2 to the power 6 minus 1. And so 6 minus 1 is going to give you 5. And so I get 7 times -32, which is equal to a -224. And that is your answer. Let me do problem number 79. 4, 8, 16. Given are the first three terms of a sequence that is geometric. Find A1 and R. So this is a geometric sequence. And so the first term is 4. The common ratio, well, I keep multiplying by 2. 4 times 2 is 8, times 2 is 16. And so that is my common ratio. Okay, that looks a little bit better. Let me do problem number 80. 1, negative 3, 9. Again, this is a geometric sequence. The first term is 1, and the common ratio is negative 3. Since 1 times negative 3 is negative 3, times negative 3 is positive 9. Let me do problem number 81. 4 thirds, 8 thirds, 16 thirds, geometric sequence. And so the first term is 4 thirds, and the common ratio, notice 4 times 2 is 8, times 2 is 16, and so 4 thirds times 2 is 8 thirds, times 2 is 16 thirds. So the common ratio is 2. 82. Sum I equals 2 to 5 of 3i minus 2. Evaluate the expression. We actually know formulas to evaluate this, but since there are so few terms, they want you just to add them up together. And so let's do this. 3 times 2 minus 2, that's when I is 2, plus 3 times 3 minus 2, when I is 3, plus 3 times 4 minus 2, when I is 4, plus 3 times 5 minus 2, when I is 5. And well, you start when I is 2 and you end when I is 5. And so I get 6 minus 2 plus 9 minus 2 plus 12 minus 2 plus 15 minus 2, 4 plus 7 plus 10 plus 13, 34. 83. Ooh, last page. So this is the last page here. Good. Okay. We'll definitely make it. Oh, yeah. Well, we'll be half hour early even. And so, sum I equal 1 to 5 of I plus 9. So this is equal to, when I is 1, 1 plus 9, I is 2, 2 plus 9, I is 3, 3 plus 9, I is 4, 4 plus 9, I is 5, 5 plus 9. And you start when I is 1 and you end when I is 5. And so I get 10 plus 11 plus 12 plus 13 plus 14 is 25, 50, 60. If I can add correctly. That's 25 and 25 is 50, 60, yeah. So let's do problem number 84. Sum I squared minus 4, I equaling 3 to 5. Very few numbers. And so when I is 3, when I is 4, when I is 5. Well, we start when I is 3 and we end when I is 5. So I get 9 minus 4 9 minus 4 plus 16 minus 4 plus 25 minus 4 is 5 plus 12 plus 21 is 38. Let me do 85. Find the sum of the first 8 terms of the sequence whose general term is a sub n equaling negative 1 to the n. Oh, so find the sum of the first 8 terms. Oh, and this is n, so let me write n here. Find the sum of the first 8 terms of the sum of negative 1 to the n. So this is going to equal negative 1 plus negative 1 squared, negative 1 cubed to the 4th, to the 5th, to the 6th, to the 7th, to the 8th. Negative 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1. That's 8. 2, 4, 6, 8. 2, 4, 6, 7, 8. 0, 0, 0, 0. So if you add these up, you get 0. Everything cancels. So the plus and minus 1s all cancel in pairs. So you get 0. 86. Find the sum of the first 4 terms of the sequence 86. The sum of the first 86 4 terms. So the first 4 terms whose general term is a sub n is equal to negative 1 to the n minus 1 divided by 5n. Okay, so let's add these up. So this is equal to, when n is 1, when n is 2, when n is 3, when n is 4. So this is equal to negative 1 to the 0, so that's a positive 1 over 5. Negative 1 to the 1, so that's a negative 1 over 10. Negative 1 squared, that's a positive 1 over 15. Negative 1 cubed is a negative 1 over 20. And so, get a common denominator, 60. And so, let's multiply by 3, 4, 6, 12. So you get 12 minus 6 plus 4 minus 3. And so this is equal to 7 over 60, if I add up correctly. 6, 10 minus 3 is 7 over 60. 77. Find the sum of the first 5 terms of the sequence whose general term is negative 7n. So negative 7 times 1 plus negative 7 times 2, negative 7 times 3, negative 7 times 4, negative 7 times 5. So I start at 1 and end at 5. So negative 7 minus 14 minus 21 minus 28 minus 35 is equal to negative 105. Let me check. That's negative 35, negative 70, negative 91, negative 101, negative 105. Correct. Okay. 78. 78. Wait one stinking second. 87. 88. I mislabeled. That was 87 was the last problem. 88. Find the sum of the first 3 terms. So the first 3 terms, whose general term is given by n minus 5 squared. So let me plug in 1, 2, 3. And so negative 4 squared plus negative 3 squared plus negative 2 squared, 16 plus 9 plus 4, 29. Let me check. That's 20. That's 13 plus 16 is 29. Yes. 89. Use a partial sum formula to find the partial sum of the given arithmetic sequence. Okay. So find the sum of the first 7 terms of the following arithmetic sequence. So I'm given the arithmetic sequence 10, 15, 20, and I want to add up the first 7 terms of that. Okay, so I know that the sum in general of the first n terms of a arithmetic sequence is n over 2 times 2a sub 1 plus n minus 1d. So the sum of the first 7 terms is 7 over 2 times 2 times a sub 1, well, the first term is 10, plus n, 7, times d, well, the common difference is 5, since 10 plus 5 is 15, plus 5 is 20. And so s sub 7 is equal to 7 halves times 20 plus 6 times 5. And so 7 halves times 20 plus 30, 50. So 7 halves times 50. And so 50 divided by 2 is 25. And so 7 times 25, 175. So if you add up the first 7 terms of that sequence, you get 175. Let me do problem number 90. We're getting close to the end. So problem number 90. Still 2 people left. So just checking to see how many people were left with me. Problem number 90. Find the sum of the first 6 terms of the arithmetic sequence. So the sum of the first 6 terms, arithmetic sequence. Negative 3, negative 5, negative 7. Okay, so we have that the sum of the first n terms of an arithmetic sequence is just n over 2 times 2a sub 1 plus n minus 1d. And so the sum of the first 6 terms is just n is 6. A sub 1 is, well, the first term is negative 3. N again is 6. The common difference is negative 2. Since negative 3 minus 2 is minus 5, minus 2 is minus 7. So my common difference is negative 2. 6 divided by 2 is 3. 2 times negative 3 is a negative 6. 6 minus 1 is 5 times negative 2 is 3 times negative 6 minus 10. And so s of 6 is 3 times negative 16, negative 48. So the sum of the first 6 terms of that sequence is negative 48. 91. Find the sum of the first 10 negative integers. So negative 1, negative 2, negative 3, etc. to negative 10. So let's find that sum. Well, we notice that this is an arithmetic sequence. And so the formula to find the sum, the sum of an arithmetic sequence, I'm going to use the other form, n over 2 times a sub 1 plus a sub n, since I know the last term. And so to find the sum of the first 10 negative integers is just, well, n is 10. The first integer is negative 1. The last is negative 11. And so I get 5 times negative 12 is negative 60. So the sum of the first 10 negative integers is, oop, oop, negative 55. That was an error. The last term was negative 10. So 5 times negative 11 is negative 55. Let me do problem number 92. I guess I'm getting too excited that we're at the end. Problem 92. Find the sum of the first 25 positive even integers. So the sum of the first positive even, the first 25 positive even integers. And so that's going to be 2, 4, 6, all the way out to 50. And this is arithmetic sequence. Okay, so let's try to find the sum of those. Okay, so since it's an arithmetic sequence, then the sum is equal to, well, n over 2 times a1 plus an. And so to find the sum of the first 25, this is just 25 over 2 times, the first one is 2, the last one is 50. And so this is 25 over 2 times 52, which is equal to 25 times 26. And so I get 650. And so if you add up the first 25 positive even integers, then you get 650. Let me do problem number 93. Find the sum of the first 11 terms of the sequence -9, -1, 7, 15 to 71, where 71 is the 11th term. Notice that this is actually an arithmetic sequence. Since I'm always adding 8 to each term to get to the next term. -9 plus 8, -1 plus 8, 7 plus 8, 15. Okay, and so the formula for finding the sum of the first n terms of an arithmetic sequence is just n over 2 times a sub 1 plus a sub n. Again, I'm going to use this formula because I know the last term. And so the sum of the first 11 terms is 11 over 2 times the first term, -9, plus 71. Okay, and so let me calculate that. So 11 over 2 times 62. And so that's just equal to 11 times 31, which is equal to 341. And so if you add the first 11 terms of that sequence, you get a positive 341. Let me do problem number 94. Use the partial sum formula. Oopsie daisy. 71 minus 9. Sure. uh, it's a long day. Okay. Let's do problem 94. Uh, find the sum of the first 5 terms of a geometric sequence. One, two, four, etc. Use the partial sum formula to find the partial sums of the given geometric sequence. Okay. And so the partial sums formula is just a sub 1 times r to the n minus 1 over r minus 1. Okay, assuming r is not equal to 1, which it is not in this case. So let's figure out the sum of the first 5 terms. The first term is 1. The common ratio is 2, since 1 times 2 is 2 times 2 is 4, and n is 5. And so this is equal to 32 minus 1 over 2 minus 1. 31 divided by 1, 31. So the sum of the first 5 terms of that is equal to 31. Let me do problem number 95. I know. 95. Solve the problem. If a sub 1 is 3 halves and r is 1 half, find s sub 5. So even though they didn't tell us, since they've given us r, I'm going to assume that this is a geometric sequence, because that's the only reason you'd give an r. The notation for geometric sequences are common ratio. Okay, so let me give you the formula. So S sub n is equal to a sub 1 times 1 minus r to the n over 1 minus r. These are both the same formulas. I usually just write it the 1 first if r is less than less than 1, and I usually write it as r first if r is greater than 1. But again, they're the same formula. You can use the same formula in either case. It doesn't matter. Okay, so let's figure this out. So S sub 5 is equal to a sub 1, 3 halves, times 1 minus a half to the power 5 over 1 minus a half. Okay, so this is equal to 3 halves times 1 minus 1 over 32 divided by 1 minus 1 half. Let me multiply and divide by 32. So it just becomes nicer to look at and compute. So S sub 5 is equal to 3 halves times 32 minus 1 over 32 minus 16, which is 3 over 2 times 31 over 16, which is a 93 over 32. And so, the sum of the first 5 terms of that geometric sequence is 9 over 32. Actually, in this case, it's actually probably easier to use the formula than it would be to find common denominators and add up all those terms. Let me do the last problem, problem number 96. And so, if a sub 1 is 1/8 and r is -3, find s sub 8. Again, we're assuming this is a geometric sequence. And so, s sub 8, s sub n, is equal to a sub 1, 1 minus r to the n, over 1 minus r. And so s sub 8 is equal to a sub 1, 1/8. Oh, actually, I usually write it the other way. Not that it matters. R to the n minus 1 over r minus 1. Ah, you're welcome. And so this is equal to -3 to the power 8 minus 1 over -3 minus 1. So this is equal to 1/8. -3 to the 8th, that's 243. No, it's not. 9. It's 8. It's 8. 65, 61. -3 minus 1 is a -4. And so this is equal to s sub 8 is equal to 1 over 8 times 6,560 over -4. So a negative 6560 over 32. I can divide 6560 by 4 by 32. I can divide by 32, can't I? Yes. This is a negative 205. So if you add the first 8 terms of that, you get an integer, negative 205. Okay, so that finishes off exam number 4 review. And I guess I'll see you tomorrow for the final exam review. Okay, so let me end that. 57 pages, really? Okay, come on, there it is.